big hello, grade 3s, and welcome to your maths lesson today. How wonderful it is that I can actually come and share this with you. I hope everything's okay at home and that you are learning some fabulous things from all the teachers at WorksheetCloud. So let's get on with our lesson now, which is brought to you by WorksheetCloud, and there is the email address on this page should you or your parents want to get hold of me and ask me any questions about this lesson. Before we do anything further, can I just ask you to get a pencil and paper ready, anything as quickly as you possibly can. If you need to go and rummage around at home to find something, then you can just pause this video and carry on playing it when you have got your pencil and your paper ready, and because we're going to do a little exercise just now. So pause it if you need to, get your pencil and paper and come back to the computer. Right, what is a maths lesson in Mrs. H's world without a good old laugh for the day? So let's just relax a bit and have a chuckle. And our first little joke for the day is, what did the triangle say to the circle? You're so pointless. The next one, who's the king of the pencil case? Now, come on, guys. I think you should know this one. I think the guys in my class might know this, because I think they told me this joke a little while ago. It's the ruler, of course. And the next one, what snakes are good at maths? The adders. Like the night adders and the puff adders. They can add, but they probably can't subtract that well. Oh dear, Mrs. Harmon. Let's get on with it. Right, and this is the level or the stage or the slide that I would like you to use your pen and your pencil, your pencil and your paper. So get it ready, because I am going to show you a tables quiz, and we are focused today on the 2 times table and the 5 times table because they are one of the more simple ones. So guys, just write down 1 to 20 as quickly as you can. Again, you can pause this video if you so desire, and wait until you've written everything down, and then you can do the answers to this. All you need is just to write the answers. So pause the video for now, and instead of me giving you a minute or 2 minutes or 5 minutes, you need to give yourself the time to do this. So pause it now, and then we can carry on, and I will give you the answers. All right, so now we are ready for the answers. So 3 times 2, and you're going to mark your work and see how many you get right out of 20. If you get some wrong, you just need to focus on the ones that you got wrong and try and learn them. And remember, I did give you something to print out a few weeks back where you have the tables that you may use and make into cards with the answers on the back that you can self-correct and learn your tables. So 3 times 2 is 6. 10 times 5 is 50. 7 2s is 14. 3 5s, 15. 7 times 5 is 35. 11 2s are 22. Just remember, you just double your little number 2 there. 8 5s are 40. And if you remember, 5 times table either ends in a 0 or a 5. If not, then it's not the right answer. 4 2s, 8. 9 2s, 18. And 8 times 2 is 16. Right, let's carry on now down from 11 till 20. 4 times 5, 20. 6 times 2, 12. 11 5s, well, you know, you double a 5, 55. 12 2s, 24. 5 5s, 25. 12 5s, 60. 10 twos, 20. Anything multiplied by 10, it just gains a naught. 2 times 2 is 4. 6 times 5 is 30. 5 times 2 is 10. So huge congratulations if you did well in that. And you also know you can practice to get better and better. Right, well done. Today I'm going to be looking at some maths rules. Okay, so everything we do has rules. If we drive on the road with our cars, we have rules. If we play a game, we have rules. So I've called this Maths Rules of the Game. And there are lots of rules here that I'm not going to be covering grade 3s. I'm just going to take a select few for this time, and then in some lessons down the way, I will add to this maths lesson and build on it. So, maths rules. Yes, you thought there weren't rules? Yes, there are. What will you learn today? You will learn rules about addition and subtraction. You will learn that addition and subtraction are best friends working together. You will learn some multiplication rules. And you will learn that addition and multiplication work together as well in partnership. Right, and of course we'll start with adding. Can we change the numbers around when we add and get the same answer, grade 3? What do you think? So let's look at 4 plus 5. We know that the answer is 9. Okay, there we've got 4 little crosses, 5 little crosses equals 9 little crosses. 5 plus 4, there we go. There's the pictorial representation or the picture form. And the answer is 9. So as you can see, the order doesn't matter, right? The order doesn't matter. The answer comes out the same no matter which way we add up our numbers. Next now, we're going to look at practicing the rules that I've taught you, or this rule, should I say, that I've taught you today about addition. So let's hear some examples. 3 plus 4 is 7. But what else do we know about those 3 numbers? We also know that 4 plus 3 is 7. 6 plus 5 is 11. What else do we know? 5 plus 6 is 11. 12 plus 7 is 19. What else do we know? 7 plus 12 is 19. Grade 3, you might notice that I'm using small numbers. And you will notice that I often do this. If I introduce something and a concept that I want you to know or to learn, I will often use smaller numbers because I don't want to bog your mind down with the big numbers. You just need to understand what I am trying to get across to you. So you're learning the rules, not big numbers. And that's why I'll always use smaller numbers. Now we're going to look at subtraction. Can we change the numbers around when we subtract and get the same answer? Well, what do you think? Let's look at the same kind of numbers that we did before. 9 take away 4. Well, there we've got 9 crosses, and I've crossed 4 out, and there are 5 left. So 9 take away 4 is 5. Right, now let's swap those numbers around and go 4 take away 9. And sometimes the children in my class, when they've subtracted, have just thought, well, I can't take 9 away from 4, so I'm just going to swap them around. And I keep saying, you can't just do that. You can't just change the sum or the problem. So let's see. There I have 4 little crosses. And look what I did in the example before. I took 4 crosses away from 9 crosses. How, guys, can I take 9 crosses away from 4? It just won't work. All right. So 4 take away 9, or 4 subtract 9, is not equal to 5. And can I just zoom in on that little equal side with a little line drawn through it? That means is not equal to, as opposed to equal to. It's the opposite of equal to. So, as you can see, in subtraction, the order does matter, not like addition. The answer is not the same when the order of the numbers is changed. And there's my happy face. Off we go to the next slide. Okay, let's practice some of the subtraction rule then, shall we? And here's an example. 10 take away 4, well, you know that it is 6. What else do we know? We know that 4 take away 10 is not 6. 10 take away 6 is 4. What else do we know? We know that 6 subtract 10, or 6 take away 10, is not 4. 12 minus 3, or 12 subtract 3, is 9. But what do we also know when we're applying our subtraction rules? We know that 3 minus 12 is not 9. Grade 3, how can you possibly take 12 sweets away from a pile of 3? It's just not possible. 12 subtract 9 is 3. That's possible. What else do we know? We know that 9 take away 12 is not 3. So there we have applied our subtraction rules, grade 3. Well done. Moving on now. Let's look at addition and subtraction a little closer. I'm getting my tongue tied. We must know that subtraction and addition are best friends. Sometimes I even think that they're cousins and family. Let's have a look what I mean. 4 plus 5 is 9. Absolutely right. 5 plus 4 is 9. So we can swap the numbers around, makes no difference to the answer. I can check my answer by saying, if 5 plus 4 is 9, then 9 take away 5 is 4. And 9 take away 4 is 5. So I've just done a check on my adding sum to see that 4 plus 5 is 9, but 9 take away 5 is 4, and 9 take away 4 is 5. So it is a good way for me to check my answers. They are cousins, they are interrelated, and they are best friends. They help each other out like best friends are supposed to. Okay, let's practice this addition and subtraction rule, shall we? 7 plus 3 equals 10. What else do we know? We know that 3 plus 7 equals 10. But what's the best friend way of working it out? How do best friends work together? Well, this is how adding and subtracting work together. They help each other out. So you can check your 7 plus 3 equals 10 by saying 10 minus 3 is 7. Or you can say 10 minus 7 is 3. Now, multiplication. What does that mean? What is another word for multiplication, grade 3? Well, it's times. It's grouping of numbers together. Can we change the numbers around when we are multiplying and get the same answer? Well, let's have a look and see. 3 times 4 is 12. You know that because you know your tables because you're clever. And there I have 3 groups of 4. And if we add 4 plus 4 plus 4, the answer is 12. Now, if I swap my numbers around, so if I swap 3 and 4 around, do I get the same answer? Well, I have to prove it, don't I? So 3 times 4 is 12. I'm saying 4 times 3 is 12. Let me prove it. I need 4 groups of 3. And there I have them. Now, let's count in threes and see if we get to 12. 3, 6, 9, 12. Right, so does it matter if we change the numbers around? Doesn't look like it. Let's do one more example just to make sure. 7 times 2 is 14. And there I have 7 groups of 2, which adds up to, or multiply together, 7 times 2 is 14. Now let's turn the numbers around and say 2 times 7. Well, there are my 2 groups of 7, and that's also 14. So, as you can see, the order doesn't matter when we are multiplying 2 numbers together, or 3 or 4, or however many numbers. The answer comes out the same, no matter which way we multiply the numbers. And moving on to the next slide. We're going to now look at the combination of adding and multiplying in one problem. And the question we're going to ask ourselves is, when we have addition and multiplication in the same problem, can we change the numbers around and get the same answer? Grade 3, this is where you need to pay very close attention, okay? And if you get a little bit tricky with this one, then go back and play it again, because repeating your learning is what helps you to understand. I often have to be shown a number of times how to do something. We don't always get it the first time, and that is fine. It's okay. Right, I'm going to now give you an example of adding and multiplying in the same problem, and I'm going to put each one in their own box. So 2 plus 3 multiplied by 4. I'm going to do each little problem separately. So 2 plus 3 is 5. You know that. 5 multiplied by 4 is 20. Okay. I'm now going to swap the numbers around, and I want you to see which numbers have I swapped around. I've swapped the adding numbers in the adding box. I've swapped those around. And what do you know about the rule of when we swap the adding numbers and we swap them around or change their order? It doesn't change the value. So 3 plus 2, well, the 3 has moved to the 2 position and the 2 moved to the 3 position. 3 plus 2 multiplied by 4. 3 plus 2 is 5 again. The same answer times by 4 equals 20. As you can see, if we swap the two numbers that are being added, so if we swap the numbers in the adding box, it doesn't change the answer. The answer stays the same. But let's look at the next situation. Again, adding and multiplying in the same problem. It all depends on which numbers we change around. That will determine if the answer stays the same or not. Have you got your ears wide open? Are your eyes glued to the screen? Are you listening with your eyes, your ears, and your mind? Because this is important. It's not difficult. Let's do the same example of numbers, 2 plus 3, and then multiply by 4. Again, 2 plus 3 is 5, multiplied by 4 is 20. That is exactly the same example I did in the slide previously. Now let's have a look carefully. I'm going to swap some numbers around, and I want you to see which ones they are. Now I've got 4 plus 3. I've taken the multiply number from the multiplication box and put it in the add box. And I've taken the 2 out of the add box and put it in the multiplication box. So I've swapped 2 and 4 around. Now let's see if this changes the answer. Remember, 2 plus 3 multiplied by 4 is 20. That's if we are doing our adding first. And later on you might learn something called BOD mass, and we will touch on that a little bit later, where you have to learn that you do multiplying always gets done first. But right now I'm not going to be using BOD mass, but don't get tired up about what I'm saying. I'm just trying to be mathematically correct. All right, so 4 plus 3 is 7. Now immediately that little adding solution or answer is different. Multiply by 2, what do we get? The answer is 14. So do you see, grade 3s, that I'll swap the multiply number with an add number, and it gives me a totally different number. So if we swap one of the adding numbers with the multiplying number, then the answer is not the same. Are you still focused? I don't want to keep you for too long, because I'm sure you want to go and play and do something exciting other than just exciting math. So let's look again. We're still in addition and multiplication. This time, before I was talking about swapping the multiply number and the add number, but now the question I'm asking is, can we change the addition and the multiplication around and get the same answer? So let me say that again. Can we change the plus and the times sign around and get the same answer? I'm going to use exactly the same example. 3 plus 2 multiplied by 4. And we so do it in 2 steps. 3 plus 2 is 5. Multiplied by 4 is 20. Now I'm going to swap around add and multiply. Let's see what happens. 3 times 2 plus 4. I have now put the multiplication sign where the add sign was, and I've put the addition sign where the multiplication sign was. Now let's see if that changes the value of the answer. So 3 times 2 now is 6, plus 4 is 10. Now, what do you notice? That answer is completely different. Right, so we have learnt then that, as you can see, when doing addition and multiplication in the same sum, the answer does not stay the same if we swap add and multiply around. We're going to practice now our rule with addition and multiplication. Let's see how much you managed to learn, changing the numbers around first. 6 plus 4 times 3. 6 plus 4 is 10. 10 times 3 is 30. All good. Now I'm going to swap the 4 and the 6 around, and I'm still going to get 4 plus 6 is 10 times 3 is 30. So that's fine. I've swapped the adding numbers around. Let's look at this example again. 6 times plus 4 is 10, multiplied by 3 is 30. And this time, let me put myself up here, this time I am swapping around the 3 and the 6. I'm taking the 6 out of the add box and I'm putting it into the multiply box, and I'm taking the 3 out of the multiply box and putting it into the add box. What happens? 3 plus 4 is 7. 7 times 6 is 42. Now you see, you're applying the rules that I've taught you in addition and multiplication, and as that was showing how what happens when we change certain numbers around. Right, and we're going to practice it again, but this time we're going to be focusing on changing plus and multiplication, the plus sign and the multiply sign around. Here's an example. 5 plus 4 multiplied by 3. 5 plus 4 is 9. 9 times 3 is 27. This time I'm going to swap the multiplication sign around and the addition sign around. Alright, so 5 times 4 is 20. Plus 3 is 23. So it doesn't work if I'm swapping the plus and the multiplication symbols around. Here's another example. 7 plus 5 multiplied by 2. 7 plus 5 is 12. 12 times 2 is 24. Right. Now, if I swap my multiplication and my addition sign around, what am I going to get? 7 times 5 is 35, plus 2 is 37. Okay, so now I think you've probably learned quite a lot about the rules of maths, and there's lots more to learn, but we'll take that next step later. So what have we learned, grade 3? Well, we've learned that 4 plus 5 is the same as 5 plus 4, and the answer is 9. We can tick that box. Yes, that's correct. We've learned that 9 minus 4 is 5, and that 9 minus 5 is 4. And we've learned that 5 plus 4 is 9, and 9 minus 5 is 4. And that is showing our best friends in addition and subtraction there, being best friends. But we've also learned that 4 minus 9 is not 5. You cannot take 9 sweets away from a pile of 4 sweets. So that gets a little cross. And what else have we learned? We learned that 3 times 4 is 12, and we learned that 4 times 3 is 12, so we can interchange those numbers and the answer will be the same. 2 plus 3 multiplied by 4 is 20. 2 plus 3 is 5 times 4 is 20. And that 3 plus 2 times 4 is also 20. So that also gets a lovely bright red little tick. Then we learned that 2 plus 3 times 4 is 20. But we also learned that if we do 4 plus 3 times 2, and we have now changed those numbers around, we don't get the same answer. So what did we swap there, guys? We swapped the 2 and the 4. We took the 4 from the multiplier box and put it in the add box, and we took the 2 from the add box and put it in the multiply box, and it did not give us the same number. 5 plus 4 times 3 is 27, because 5 plus 4 is 9, and 9 times 3 is 27. But 5 times 4 plus 3, now we've changed our numbers around. We've changed our operation signs around. And what did we get? 5 times 4 is 20, plus 3 is 23. We've practiced. This is what we have learned. And I hope that it's helped you to understand. So, grade 3s, thank you so much for having me in your homes today, sharing my maths lesson with you. I'm very privileged to be able to do that. What you can do now is go and download the worksheet on WorksheetCloud.com. You can finish the worksheet, complete it, then look at the answers, or the memorandum page, or memo page as I call it, and you can mark your work. And also remember, you can email me at any time if you've struggled with anything, and I will do my best to help you. So be happy, grade 3s, be safe, be at peace, help each other out, be kind to each other. And until next time, this is me, Mrs. H, saying goodbye.